Okay, today we're going to add in an extra little touch to help us figure out possible roots. Not only will we make our list from P's and Q's, but Descartes' rule actually helps us decide if we want to use positives or negatives. So it kind of limits it even more for us and gives us a little better feel for it. So what it does is it tells us the number of possible positives and the number of possible negatives, both real and imaginary roots, right? So as you're looking at this, you're going to look at just the original function just as it is, and you're going to count the number of sign changes. I'll show you what we mean by that in a minute. But if you count the number of times the signs change, that tells us how many possible positive real solutions there are, but then we have to decrease that by 2 every time. So if we count 3 sign changes, it's possible there's 3 positives, but it's all just as possible if we take the 3 and we reduce it by 2, it's just as possible that there's only 1 positive root, right? And then same thing, if you had 4 to start with, it could be there's only 2. It could be that there are actually 0, because 2 minus 2 is 0. All right. To find the negative roots, what we do is we actually plug a negative x into the original function and recalculate the signs. Again, I'll show you why we're going to do that. Sorry about that. So again, we plug negative x into the original. We look at what the signs look like then, how many sign changes we have, and we take that number, and that's a possible number, and we decrease by 2. Why do you think we decrease by 2? Well, because it's possible we have imaginary or complex rather solutions, and those complex solutions, remember, always come in a conjugate pair. So if I have 1 complex, I have 2. There's really no way to help us figure that out. So that's why we deduct 2 each time. Once we know the possible positive or the possible negative, then we can base our answer on that. Alright, so we'll look at what this looks like. First thing that I need to convince you of, though, so the purpose of this little part of your notes is simply to, and this may not even be in your notes, but the idea is to help you understand why it's better to know how many positives, how many negatives. So for instance, if we just give you 5 random doors and tell you there's a blue dot behind one of them, or you win if you find a blue dot, but you don't know, maybe there's 5 blue dots, maybe there's no blue dots, maybe there's, like this example, 4 blue dots and only 1 red. If I knew there were 4 blue dots and 1 red, I'd be wagering a lot of money. If, however, I was down here at the bottom and I knew there were only 2 blue dots, well, I only have 2 out of 5 possibility of getting the blue dot. So the idea, again, this is just to help you grasp that it is a good idea to know how many positives or how many negatives. It just helps you make a better choice. Alright, so this is what our problems are going to look like. If you look at example 7, here are our steps. It's basically 6 steps. First thing you want to do is make sure you're in standard form. We are. Next thing you want to do is check to see if there is a greatest common factor, preferably of x, but of anything really. And x is the one thing, though, that we really worry about. This does not have a greatest common factor of x, so what that tells me, my 0 column, I'm going to have no zeros, no x equals zeros. I only get a 0 as a solution if I have a GCF of x. And if I have a GCF of x squared, that means I get 2 zeros. If I have a GCF of x to the 5th, I'm going to get 5 zeros. So that's what number will go in this column. This never changes. It's always your number of greatest common factor, x's. Okay, so that's second step. The third step is you're looking at your original function after you've pulled any x's out. We're good. And you're counting the number of times the sign changes. Meaning if it goes from a positive to a positive, that's not a change. Here we start out positive to negative. That is a change. Negative to positive, also a change. Positive to negative, also a change. So I had 3 possible positive roots because I had a sign change 3 times. Also, the total is going to be your degree. Degree tells us the number of roots. Well, if the 3 are all positive, that means there can't be negative, there wouldn't be complex, they would all be positive. So these 4 columns should total your total, because that's what total means, right? So 3 should add up to all of these. All right, the way the negative part works, we'll come back to the decreasing here in a moment, but the way the negative is, you plug a negative x into each of the x spots. Then you have to decide how that power on it is going to affect a negative. Well, I've got a negative times a negative times a negative. Negative x to the 3rd power. Every 2 make a positive, so there's a positive x times negative x. So when it's an odd power, it stays negative. So that's going to be a negative x times a positive 3, or a negative 3x cubed. When you've got a negative to an even power, they buddy up. Every 2 make a positive. So this would be a positive x squared times a negative 2. So that's still minus 2x squared. When I add a negative, it's the same thing as minus x, and then I bring my minus 1 down. Notice, from here to here, there's no change. Negative stayed negative. Stays negative, stays negative. There is no change. All right. The next thing I need to do is to decrease my powers, because I might have 3 positives, but I can reduce that by 2. So for anything you put in these columns, you're going to subtract 2 as long as it stays greater than 0. All right, so when I subtract 2, that's 1. Negative is not going to change because 2 minus 2 still, or 0 minus 2 would give me a negative number, so that won't work. I know I'm still supposed to get a total of 3, though. That extra amount comes in your complex column. This is kind of your makeup column, if you will. That's where you make up the difference as you subtract. And I don't have any zeros still. And 1 and 2 make 3. And I've got both of these numbers. I can't subtract 2 and still stay greater than 0. Let's take a look at example 8. All right. All I did first, I noticed I had a greatest common factor of x, so I've already pulled that out for us. So our function now equals x times, and it decreased everything because I have to have a constant at the end. I know that this is still a 7th degree, so I'm still going to have to add up to be 7 here. When I look at my sign changes, I'm starting inside. That is positive, it goes to negative, so that's a change. Negative to positive is a change. Positive to negative is a change. Negative to negative is no change. Negative to positive is a change. So there's 1, 2, 3, 4 times the sign changed. And if you want to go ahead, you can reduce that. That would be 2 and 0 also. All right? So then I've got to plug negative x in for each of these. Remember, odds mean that the x stays negative. So that's negative x to the 7th times 5. So negative 5x to the 7th. This to an even power stays stays positive rather. And so that's positive x to the 6th, but times a negative 4. So that's minus 4x to the 6th. The x to the 4th would mean this stays positive, and it's times a positive 3. So that'll be plus 3x to the 4th. That is a negative x cubed because cube is odd, and it's times this negative 1 in front of it, so that becomes a positive x cubed. The x squared would become positive, and it multiplies times a negative 2, so that's negative 2x squared, and then plus a negative, so I'd have minus x at the end. Looking at your sign change, you go to negative, so there's no change. Here's a change. You stay positive, no change. Here you go to negative, so that's a change. Now you're still negative. So there's only 2 times with the negative, f of negative x, that changed. So I could have 2, or I could have 0. Interesting thing, you've got to repeat this, because it could be that you have 4 and 2, and then could be you have 2 and 2 and 0 and 2, but you could have 4 and 0, decrease this by 2. Could have 2 and 0, you could have 0 and 0. So you've got to redo each time. I did have a greatest common factor, and his power is an understood 1, so there's 1, 0. 4 plus 2 is 6, and 1 makes 7. 2 and 2 is 4, and 1 makes 5, so there would be 2 here. There's no complex up top because I already had 7. Here, 2 and 1 is 3, so there might be a possible 4 complex. All right? So every time my 1 stays, so 4 and 1 is 5, so it could be 2 here. 2 and 1 is 3, so this might be 4. And 0 and 1 is 1, so it could be that there's 6 in order to total 7 actual roots. So you've got 6 different possibilities. As you look through, there's a better chance probably of getting a positive, so I would probably guess a positive. All right, looking at example 9, this is how we're going to use this. That pulls out an x, and I'm going to pull a negative. That's x cubed minus 2x squared, plus 2x squared, minus 5x minus 6. This, if it would group, I would do that, but it won't. So I'm going to make my p's and q's. Apparently every time we're using 6 and 1, not always, but this time again. So my possible are both positive and negative, 1 over 1, 2 over 1, 3 over 1, and 6 over 1. When I make my table, and the table is kind of just for you, but we will be having you fill it in. I should have 4 roots every time. When you look, there's only 1 sign change for positives, so that won't decrease. The number of negatives, I could plug in. I know I will get a 0, and complex-wise, it could be that there's 2 complex, that would make 4, without even checking my negative. Nice thing though is I know there has to be a positive, so I'm going to guess a positive number until I find one that works. I would try 1. I'm a big proponent of doing that, and again I'm using the coefficients from the partially factored form, and that'll be that 1 does not work. Look, that's negative 2, so I do not get a remainder of 0. No. So I'll guess something else. Again, one of the positives have to work, so keep going there, and as we go, 2 is 4, is 8 is 3, there's 6, so I found a root. That means I could factor this portion to have x minus 2, and then that would give me an x squared plus 4x plus 3, and still have my negative x. This will factor x plus 1 and x plus 3, so I've got all my roots, all my factors, and that's what we're trying to do.